And today we're going to be discussing something a little bit more controversial. We're going to be diving into a hotly debated scientific topic in Earth sciences. The idea referred to as the Younger Dryas Impact Hypothesis.
Now that's an ambitious starting point. Anton's diving straight into the deep waters of controversy. Cosmic catastrophes have always carried this dual edge, captivating narratives on one hand and the sobering weight of evidence on the other. The Baffin Bay angle adds fresh intrigue.
Also referred to as YDIH. And the idea that proposes that a massive cosmic event, possibly a comet or some kind of a massive asteroid, dramatically altered Earth's climate approximately 12,800 years ago. And because of this bold claim, it generated a lot of debate in the last few decades, with a lot of debate basically becoming super heated. But recently, another study just came out, claiming to find even further evidence for the impact in a somewhat unexpected place, deep-sea sediment cores from what's known as the Baffin Bay. A location you see on the map right here, very close to the Baffin Island, but also very close to Greenland. But whenever we discuss these ideas and these propositions, especially involving cosmic catastrophes, it's very easy for the discussion to become sensationalized. And well, my goal today is to try to cut through all of this hype and focus strictly on facts. Facts and evidence presented in this study, and of course its claimed importance, but crucially also significant criticisms and alternative explanations proposed by many more scientists when talking about this unusual impact event. And so to start, let's set the stage. Let's start with the Younger Dryas. This was a sudden intense period of rapid cooling that happened roughly around 12,000 years ago. And it lasted for about 1200 years, plunging parts of the northern hemisphere back into the near glacial conditions. But the thing is, this happened when Earth was supposed to be generally warming up following the last glaciation period right at the end of the last ice age, which of course made this event somewhat intriguing. And so the proponents of that impact hypothesis have always suggested that most of this was very likely caused by massive forest fires that very likely resulted from the impact itself, but also the vast amounts of meltwater that was released from ice sheets that eventually led to global cooling.
Well now, this framing is crucial. Earth's climate system has a history of abrupt shifts without any space rock needed. The Atlantic conveyor collapse fits neatly with past oscillations. The impact theory sounds dramatic, but nature often has its own complex cycles.
And they also suggested that this event very likely resulted in the extinction of the megafauna across the planet, such as, for example, mammoths and some of the megafauna in countries like Australia. But this obviously had significant consequences for human societies at the time. However, it is very important to understand that the Younger Dryas itself is not a unique climatic event. In fact, many scientists believe that these unusual cooling periods seem to be a normal part of deglaciations. We've actually discussed this previously in one of the videos in the description, but these can easily be explained by an Earth's long-term climate cycle, with the most widely accepted idea involving oceanic currents, specifically a significant reduction or even a shutdown of the so-called North Atlantic conveyor, a major oceanic current that generally circulates very warm tropical waters northwards. And in this case, the current shutdown may have been caused by an influx of fresh meltwater from a lot of glacial lakes that used to exist when the Earth was much cooler. And so, in most scenarios, this particular impact event was never even required to explain any of this, which is basically by far the most widely accepted idea right now, with quite a lot of evidence behind it. But now let's turn to this new research by Christopher Moore. And here this was based on 4 marine sediment cores from Baffin Bay, relatively close to Greenland. We're essentially talking about these cylindrical extracts from inside the sediment that have not been affected by much for thousands of years. And these particular cores were chosen strategically because they're very far from potential human contamination and because they're highly laminated, essentially suggesting that sedimental layers have been undisturbed and were very likely created in pristine conditions.
Curious, isn't it? Deep-sea cores offer a kind of time capsule untouched by human interference. Radiocarbon dating stacked against undisturbed laminations gives this study some real backbone. If anomalies exist here, they can't be brushed aside lightly.
And all of these cores were extracted from the water depth of approximately 500 meters to 2400 meters, so this was from the depths of the ocean. And they were also dated. Here the age of the sediments and the material found inside the sediment has been established pretty accurately by using radiocarbon techniques and what's known as Bayesian modeling, an interesting dating technique that allows researchers to establish an age depth model for every core. So basically, when you look at the core that's approximately 10 meters in length, you're kind of looking at something that's maybe about 10,000 years in age. And so essentially they were able to confirm several layers corresponding to the Younger Dryas period. And so what exactly did they discover? Well, here the study reports abundance peaks in several key deposits, and specifically abundance of microspherules, very tiny iron and silica-rich spherical particles that are usually micrometers in size. And here scientists found evidence of high-temperature minerals and aerodynamic shapes, with some of them even containing bizarre soccer ball patterns, indicating very rapid cooling from a molten state.
Now this is where it gets tantalizing. Microspherules and melt glass always stir excitement. The cometary signatures, nickel, low oxygen, sound persuasive, yet the scattered peaks remind me how messy Earth's record can be. Nature rarely leaves us a clean forensic trail.
But critically, the analysis suggests that these microspherules were predominantly terrestrial in origin, with only about 2% being extraterrestrial. But I guess even more importantly for the study, most of them were found to peak in abundance around the same time when we expect the Younger Dryas period, with the overall abundance dropping off dramatically above and below the specific boundary. Although as you can see from this image, there were definitely other peaks during other times, and even the peak around the Younger Dryas period is not exactly localized. I mean, right here you can actually see this is approximately like 1,000 years or so. They also discovered some melt glass and metallic dust particles, which are essentially twisted deformed metallic particles whose composition was apparently consistent with cometary origin. Here are just some examples from the study. And specifically they contain iron with low oxygen and high nickel content, with the chemical ratios overlapping cometary dust and extraterrestrial micrometeorites, suggesting potentially cosmic source for some of these particles. And there was also melt glass, or melted grains suggesting high temperatures, and certain particles containing platinum anomaly. But one of the main points the study tries to make here is in regards to potential human contamination. Here, the emphasis is on the layer itself and its association with the deep marine sediments. And this addresses one of the major criticisms from one of the previous studies that suggested that many previous samples from previous studies may have been just anthropogenic or industrial contamination resembling something from outer space. And so given the depth and the remote location, this is extremely unlikely. It's unlikely to be industrial contamination. But now, having discussed this, let's talk about some alternative explanations for the abundance of these microspherules, which is actually something that has been mentioned previously in a lot of scientific studies focusing on very similar spherules discovered elsewhere. For example, in some of the previous studies, it has been suggested that some of these could be just your typical micrometeorites coming from space at all times. This is referred to as meteoritic ablation or constant cosmic influx.
Stepping back, one appreciates how carefully alternative explanations are eliminated. Volcanoes, mantle upwellings, even wildfires. Still, exclusion isn't confirmation. The idea of a low-altitude airburst feels plausible, almost Tunguska-like, but the burden of proof remains heavy.
But here the scientists briefly mention this idea and do suggest it's unlikely to be just meteorites because of a very low magnesium oxide content. And so here this chemical difference potentially suggests that these are not normal meteorites or normal cosmic dust. It's also unlikely to just come from the mantle itself because materials ascending from the mantle are not known to produce microspherules. And it's also unlikely to be volcanic activity because none of these core sediments seem to show any evidence of tephra or detectable sulfur expected from volcanic eruptions. As a matter of fact, this particular location seems to show no signs of volcanic activity within about 100 years of the Younger Dryas period. A lot of these samples also contain too much iron, which is not expected from volcanic eruptions, which normally produce silica-rich microspherules. These cannot also be created by wildfires, because wildfires normally don't reach hot enough temperatures, and it's once again impossible to be anthropogenic. It's unlikely to be coming from pollution. And so based on these initial dismissals, the overall conclusion from the study suggests that there might have been some kind of an extraterrestrial impact, which potentially served as the source for these microspherules 12,800 years ago, but primarily formed as a result of melted terrestrial material mixing with a small amount of extraterrestrial material, which is actually consistent with the formation of low-altitude airburst or surface impact by a cometary fragment. And so that's the overall conclusion here. But I guess let's address the elephant in the room. Despite the claims of robust evidence, it is crucial to reiterate that the Younger Dryas impact hypothesis remains very contested and is widely rejected by relevant experts for very important reasons. And so let's discuss these right now, starting with the most important one. And also actually just a quick side note. If you look at the authors behind this paper, these are actually exactly the same authors that have been trying to fight for this hypothesis for the past few decades.
On second thought, the reproducibility gap is damning. Science thrives on independent confirmation, and if markers can't be found consistently, confidence collapses. This isn't new. Extraordinary claims, as Sagan quipped, demand extraordinary evidence.
And they've actually been using very similar techniques and somewhat similar evidence. But the other side of the argument comes from a much wider community, and their evidence is potentially even stronger. And so first, let's discuss the microspherules and a very important fact that in previous studies, there was a major lack of reproducibility, which is crucial for scientific studies. In the vast majority of studies released by these authors, actually going back more than a decade, a lot of these impact markers, such as nanodiamonds, magnetic spherules, and even microspherules, have not been consistently reproduced by independent researchers. Let me just rephrase this again just so that it kinda clicks. When separate teams from other universities try to actually analyze similar samples and try to recreate similar results, in many cases, and actually in most cases, they couldn't, which created a major issue for the Younger Dryas impact hypothesis. Without being able to reproduce the same results, none of this is actually good science. On top of this, we have a very common criticism that a lot of these so-called impact markers, such as carbon forms, magnetic grains, and spherules, are not unique to impact events. As a matter of fact, many of them can be recreated through very common terrestrial processes. For example, the idea of black mat layers that have been previously cited by many studies, suggesting they were created through widespread fires on the planet, have actually been shown to be consistent with the formation of soils and wetland deposits over completely different periods of time, thousands of years apart. And no fires needed, no impact needed either. That, by the way, has never been addressed by the scientists behind the study. Likewise, there's always been a very big inconsistency with the proposition for the impact itself.
Gosh, this really highlights the complexities. Markers like carbon forms or black mats can so easily arise from mundane earthly processes. The scattered timelines weaken the case further. A true impact should leave a crisp, singular boundary like Chicxulub's global layer.
Or the impactor that collided with the planet. Some studies suggested it was a direct impact, some studies suggested it was a air bolide exploding in the air, and some studies suggested that it was multiple impacts over hundreds of years, with all these hypotheses producing different results and using different data. And one of the bigger issues here was timing discrepancy. You can actually see it in this image as well. There is an apparent age discrepancy of up to 2 centuries between different sites used in previous studies, and even between this site. As a matter of fact, even in this sample, the spherules are not localized to that one event that happened exactly 12,800 years ago. They seem to be more or less spread out and seem to be located hundreds of years apart. And so if these markers were deposited at different points of time, we cannot logically attribute this to a single cosmic impact, because that would definitely create a single layer very similar to what we see from the famous impact that killed the dinosaurs. And of course, there is no crater. Even though for many years researchers were hoping that this was the crater discovered by NASA almost a decade ago. But the Hiawatha impact crater, that you can learn about in one of the videos in the description, is now believed to be possibly up to 3 million years old and not 12,800.
Truth be told, the absence of a crater remains the Achilles heel. Without a smoking gun structure, the parallels to Tunguska feel speculative. Add the staggered megafauna extinctions and even whispers of misconduct. Credibility takes a serious hit.
So this is definitely not the crater they're looking for. And though obviously this could have been some kind of an airburst similar to the Tunguska event, once again there's just no evidence for anything. Likewise, even though the megafauna extinction has been mentioned previously, today many studies have confirmed that megafauna extinctions also did not happen at the same time. many of these massive, wonderful animals seem to have disappeared at different timescales, and, not surprisingly, kind of correlating with the arrival of humans. So it's a lot more likely that humans possibly just ate them. I mean, they do look kind of delicious. My apologies to my vegan and vegetarian viewers. And studies that suggested there was some kind of a human population decline around the same time, once again found absolutely no evidence. But at the same time, there's always been this concern with credibility. Quite a lot of critics have previously raised concerns that some of the researchers associated with this hypothesis might have actually conducted scientific fraud and possibly manipulated certain images in various publications. Once again, we've discussed this in one of the videos in the description, and that of course is a huge issue. I mean, I'm not saying any of the scientists here did this, but because the proponents of the hypothesis have been caught doing this, how can we possibly trust them afterwards? And so I guess what's the overall conclusion based on everything I've just said? Well, this new Baffin-Bay study by Moore does present us with interesting findings and unusual anomalies that right now does present strong evidence for some kind of an extraterrestrial impact, possibly around the same time as the Younger Dryas. However, because of previous problems, it is once again important to understand all of this is super controversial right now, and only very thorough follow-up studies that can possibly recreate all of this independently can then be trusted. And so without reproducibility of these results, we're not going to make any conclusions yet. And that's because the scientific process is all about building evidence.
Frankly speaking, Anton sums it up well. Provocative data, but far from settled science. The integrity of inquiry lies in replication. If future cores elsewhere echo Baffin Bay's anomalies, the hypothesis may gain ground. Until then, it remains a tantalizing what-if.
Now, it's obviously also about challenging assumptions, which is what this study does, and also about constantly refining our understanding, but once again, it all depends on very, very good evidence. And because this is such a fascinating research, we'll very likely see more studies very soon, and we'll definitely discuss counter-arguments as they come. And so until those future studies or until we learn something else, thank you for watching, subscribe. Either way, stay wonderful, I'll see you tomorrow, and as always, bye bye.